All right, 1.3. We have 12 basic functions. And each of those basic functions have properties that help to identify them. The first one we are going to start with is called the identity. That function, when you graph it, is a perfect line through the origin. This graph, also known as linear, is the equation or the function y equals x. And of course, we can then take that basic function, translate it up, down, right, left, flip it, stretch it, whatever. Okay? So let's talk about some things we know about this wonderful basic function. First of all, look at it. All right? Is this function odd, even, or neither? It is odd. Thank you. If I were to put my pencil right here at the origin and I flipped it over, do I have the exact same thing? Yes. So this is an odd function. It is odd. If it is odd, that means that it is symmetrical about the origin. The domain for a linear function is always negative infinity to positive infinity. And the range for an identity or linear function is always negative infinity to positive infinity. All right, so that means that on that graph, every real number exists. Okay? That's number one. Our second basic function is they call it the squaring function. I'm going to call it the quadratic function. All right? The quadratic function is a parabola. There we go. That is our quadratic function. The function is y equals x squared. This is an even function, right? Because I can fold it on the y-axis and the two sides meet up, correct? This is even. It is also then, we can say it's symmetrical about the y-axis. So that means I can fold it on the y-axis, the two sides meet up. For a quadratic or a parabola, the domain is always negative infinity to positive infinity. And the range. Who can tell me what's the range for a quadratic function?
0 to infinity.
Very good. It is 0 to infinity. Now, sometimes they refer to this as the squaring function because x is squared. But again, quadratic is what we're used to seeing, right? The third one I want to talk about. Oh, let me not go that far on you. The third one is the cubic function. The cubic function, here is the graph for a cubic function. It is what I always refer to as that S-curve, right? Hopefully you can draw it a little bit better than I do up here. All right, this would be y equals x to the third. Now, in y equals x to the third, this is odd. How do I know it is odd? It is symmetrical about the origin, right? If I were to put my pencil here and rotate it 180 degrees, do I still have the same thing? I do. So this is symmetrical about the origin. The domain for a cubic function is negative infinity to positive infinity. The range for a cubic function is also negative infinity to positive infinity. So far, our first function, the identity or the linear function, and our cubic function are very similar to one another, right? They have a lot of the same properties. All right, let's go to the next one. Let's go with the reciprocal function. The reciprocal function, which is y equals 1 over x, is a graph that looks similar to this. Whoops. Gosh darn it. Sorry about that. Let me fix that. It is a graph that has two separate pieces. Alright. So this reciprocal function, this is also odd, which means it is symmetrical about the origin. What do you notice, however, for the first time in all the functions we talked about? What do we now have in this function? If you look at the graph, it's approaching somewhere in both directions. So what do we have?
An exponential.
No. You could try though. An asymptote. We have asymptotes. So in the reciprocal function, there is a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Which means the domain, since it can't exist at 0, is negative infinity to 0, 0 to infinity. The range, since it can't exist at 0, is negative infinity to 0, 0 to infinity. Any questions so far? We've done 4 out of 12. What do you think? So if I was to say to you, somebody tell me one function that is odd. Who can tell me something that's odd? Go ahead, Maya, what you got? The reciprocal function is odd. All right. Do we have another function so far that is odd?
Identity.
The identity. Very good. That is odd. What else?
Quadratic.
Cubic. Very good. Cubic is also odd. So far we have 3 odd. What was quadratic? Even. Very good. All right. Let's go to function number 5. This one is the square root function. A square root function is, again, one of those that we graphed last year and then we translated. Square root function, or y equals the square root of x, starts at the origin, is like the top half of a parabola, right? If it's on its side, just a curve. is this symmetrical anyway? All right, so we're going to say that it has no symmetry.
If you flip it across every axis, then it just looks the same but mirrored.
But is the function there when you flip it over to it? Okay. So in order for it to have symmetry, we have to be able to fold it or move it somehow so it's back on itself. Is it?
Oh, so you're saying like if that needs to be curved, it would have to have another curve on the other side.
Correct, in order to have symmetry. Okay? In order to have a line down the middle of it somewhere that you can fold on. All right? Okay. This one, there are no asymptotes either. Correct? So we're also going to put there are no asymptotes. All right, but its domain. Tell me about its domain. Looking at that picture, what's the smallest x value we can have? 0. That's going to be a bracket, 0 to infinity. How about the range? What's the smallest y value we can have? 0. Very good. To infinity. So if I were to ask you, is this odd, even, or neither? What is this? Neither. Good job. All right. Number 6 is the exponential function. The exponential function. Here's my graph. The exponential function is close to the x-axis and then increases, right? It's really, really, really close to that x-axis. This is y equals b to the x. In this exponential function, does this have symmetry? It does not. So it has no symmetry. Okay? However, it is approaching the x-axis. So what is that called? It has a horizontal asymptote. There is a horizontal asymptote at y equals 0. So, our domain then, since there's no vertical asymptote, what is our domain? Good. Negative infinity to infinity. I agree with you. Nice job. How about the range? Yes, 0 to infinity. But does it touch 0?
No.
So it has to be a parenthesis, 0 to infinity. Okay? All right, so we've done half of them so far. I want to talk a little bit more about all of those. Let's go back to the very first one. Maybe I'll go back to the very first one. If I can get back to there. Move this out of my, maybe I'll move this out of my way. All right. So our very first one. I want to add one more word to describe this one. Did I, when I was drawing that graph, have to pick up my pencil at all? No. So we call this graph continuous. Just means that I didn't have to pick my pencil up when I drew it, right? How about this one? When I draw it, do I have to pick my pencil up in order to complete it? No. So this is also continuous. Talk about the cubic function. In this one, to draw this S-curve, did I have to pick my pencil up? No. So this is also continuous.
Reciprocal is not.
Correct. Very good. In the reciprocal function, there's no way to draw this graph without picking up my pencil. So this is discontinuous. All right. Next one we have is the square root. What do you think that one is? Is that continuous or discontinuous? Continuous. I start here and I draw, right? So this is continuous. And last one, exponential that we have so far. The exponential graph, is that one continuous or discontinuous? It is also continuous. All right, so looking at those six, if I asked you which of those six are neither odd or even, which six can you tell me, or which ones can you tell me? Which ones are neither? They have no symmetry at all. Okay, the exponential function and square root function. Good. All right. Would what? No. Right, because exponential, I can't fold it on the y-axis and have the two sides meet up. So there's no symmetry, which means it is actually would be a neither. Okay? All right, let's go to function number 7. That is the natural log function. The natural log function, or y equals the natural log of x. That graph was a curve that approached the y-axis but never ever crossed it. Because remember, you couldn't have a value less than 0 of a natural log, right? All right, so first I'm going to say or ask you, is there any symmetry? No, correct. There is no symmetry. Okay? Does this have an asymptote? Yes, it does. It has a vertical asymptote at x equals 0, or the y-axis, right? It's approaching this axis but never crossing it. All right, so if that's the case, our domain then goes from 0 to infinity. But what about our range? Very good. It is negative infinity to infinity. Is this one continuous? Yes, it is continuous. All right. Number 8. You guys are doing great. Function number 8. Let's go with the absolute value. Oops, value. I can't spell. Sorry. Absolute value. That would be y equals the absolute value of x. What did that one look like? A v. Very good. It's a v. All right. So is this one odd, even, or neither?
Neither. It's odd. It's definitely odd because it can be reflected even.
It is even. Because why, guy? Yes, it is symmetrical about the y. So anytime you can fold on the y-axis, the two sides meet, that makes it even. Does it have any asymptotes? No, it does not. Good. All right, so let's talk about its domain. What is the domain in this case? Oh, domain, remember, is all your x values. So does this go forever that way and forever that way? So it's negative infinity to positive infinity. It does. It stops at 0 and goes back up. But you can also have 0. Can I have the absolute value of 0? Okay. Talk about the range. The range is your y values. So the range could be bracket 0 to infinity. Is this continuous or discontinuous? Continuous. All right, let me add one more thing because you guys are so awesome. Is this bounded above, below? Yes, this is bounded below. Again, because it can't go any lower than this. Was there another graph that we have drawn that is bounded below? Quadratic. Good, Ty. Okay, was there another one that we had that was bounded below? Exponential. Awesome. And how about, there's one more that we've done so far. Square root. Good. Those are all bounded below. We get out of here at 10 after, right? All right. So let's do this. I'm going to keep talking for a few more minutes, and I'm not going to get through all the notes today. So my plan then is going to be, if you let me finish, do a little bit more, get a couple more functions in here. We won't have any homework today. Nice, right? Won't have any homework today, and then tomorrow we can finish up our notes and get into the activity I originally had planned. Okay, but I just need you using your listening skills for the rest of it real quick. So after we talk about the absolute value one, let's see, let's go to, oh, this is one of my favorite ones. This is called the greatest integer function. The greatest integer function is written as y equals int of x. What that means is that your y value can only be whole integers. So it actually looks like this. Okay? They call this a step. Maybe. Step function. All right? Because it looks like stairs going up, right? Taking steps. All right. So, you guys tell me, do you think this is symmetrical? Well, if I went like this and folded on the y, does that meet up? No. If I were to put my pencil right here and rotate 180 degrees, it would be close. If I were to put it 180 degrees, let's talk about that. This one would rotate over to here, right? This one would be over here. I agree. So is this exactly the same as this one? It's shifted over just a little bit. You'll notice that this piece right here is on this side, but in a rotation, this piece is on the other side. So is it exactly the same?
No, I thought that was your drawing skills. I didn't know that you do that.
Okay. All right. So this has no symmetry. All right. What else can we say? There are no asymptotes. Yeah, it'd be classified as neither. Okay? So it says no asymptotes. What else can you tell me about it? Is this continuous or discontinuous? It is discontinuous. What else can you tell me? So this would be really hard to write the domain and range for, right? Because it's going to keep skipping. Can you write a range, for example, that starts here and goes here, and goes here, or here? I mean, that would be really, really hard to write a or a range for. Domain, same way, right? It's got all these places that it's got to skip over. So it'd be really hard to write the range for it, or the domain for it, yes. Not on the domain. This, and it's not really bounded. This one, this is a strange one. It's a unique one. We don't see it a whole lot, but it is a function. All this says, what this really means, is let's say I plug in x is 1.5, right? If I have the int of 1.5, that means my y value is 1. It always goes to the lower integer, okay? That's all that means. So 2.1 means that it's actually 2. That's all it is. So, but that gives them those straight horizontal jumps in there. All right, so I guess we'll stop with that one. We have, what, 3 more to go? Okay, so we'll finish the last 3 tomorrow. And then we're going to get into an activity where we're going to try and place these 12 functions with all their different properties. You guys get to, like, look at the graph and see if you can figure out where it goes. Okay?